And also, too, guys, you'll notice that if you're working with the right formula, guess what will happen? Your units will actually come out to be the correct thing, okay? Next problem, okay? For a chemical reaction, delta G is equal to 42.5 kilojoules per mole at 298 Kelvin, and delta H equals 25.7 kilojoules per mole. Calculate the value of delta S. You are looking for delta S. You're looking for delta S. And so now, I'm going to go ahead and rearrange this problem, right? Or this formula where I'm going to go ahead and pull delta H to the other side. So I end up with delta G minus delta H equals negative T times delta S. Now, I need to get the delta S by itself, so I'm going to divide both sides by negative T. So now delta S formula, okay, is equal to delta G minus delta H divided by negative T. So listen, when you all are plugging these numbers in, okay, look at what you got. Notice how some of these answers look the same, right? One is positive, the other is negative. If you have the wrong answers, if you have the wrong numbers in, you're going to end up with the wrong problem and the wrong formula. So you want to make sure that you look at the numbers the way that they should be, okay? Now, our delta G is, matter of fact, I'm going to carry this down here. So right here, our delta G is equal to 42.5 kilojoules per mole minus our delta H is 25.7 kilojoules per mole divided by the temperature. Divided by the temperature. The temperature here was 298 Kelvin. So, and that's negative, okay? So I'm going to put that on the very bottom right there. Now, here's something else that I want you guys to keep in mind, okay? When you look at these examples right here, when you look at your problems, okay? You see how there's a negative sign on the very bottom? And so we can at least determine that one of these answers is going to be the correct one, okay? Based on what we got right here, all right? So, because I need the space, 42.5 minus 25.7 gives me 16.8, okay? 16.8. But now I'm going to go back up here for a minute. Take a look before I continue. What is wrong with this problem? Take a look before I continue. What is wrong? It's not that it's wrong, but it's incomplete. It's incomplete. You see, the answers right are in joules, right? See that? That's right. You've got to convert the kilojoules. So let's say that we did not do that, right? And we just plugged in 16.8 divided by 298. We would get 0.056. But remember, if you get 0.056, one of these two answers here is correct between letter A and letter B. So we know it's not letter C. We know it's not letter D. But we also know that since the answer should be negative, it's letter A. So if we go back over here, okay, and multiply that answer times 1,000, we get 56.3 or 4 when you round it off. Negative, because that sign right there on the bottom is negative. You would multiply that times 1,000 and you would get 56.4. So you've got to convert your answer to kilojoules, okay? Convert it to joules. So convert your kilojoules to joules by multiplying your final answer times 1,000. So therefore, you end up with the answer of letter A, okay? We're now going to look for delta H, okay? Because you are looking for your delta H, this formula is easy to manipulate or redo in order to solve for your delta H, okay? So here's what we're going to do. Because I'm looking for delta H, I know that I can just bring over T and delta S, but it's going to be positive. So my delta H formula is going to equal to delta G plus T times delta S. That's going to be my formula right there. I'm leaving delta H by itself. I'm going to take the T delta S to the other side. Because that was a negative, when I add T delta S to both sides, that cancels out. And that's why I wrote it this way right here. Okay? So now let's go ahead and look at what we got. A reaction has a delta G of negative 15.2 kilojoules per mole at 325 Kelvin, and delta S is 78.5 joules per mole dot Kelvin. What is the delta H for this reaction? Okay, now let's go ahead and see what we can get for our problem here now, okay? Look at your problem. There is something that's sticking out like a sore thumb. Delta G, look at the units. The unit here is kilojoules per mole. The temperature is 325 Kelvin. But the delta S is in joules per mole dot Kelvin. You all should already know that you're going to have to do what? Convert the 15.2 kilojoules to a joule by multiplying it times 1,000, okay? And that's negative 15.2, guys. But the point of the matter is you still have to convert it, okay? Whether it's a negative or positive, you just have to multiply that times 1,000. And 15.2 kilojoules is equal to 15,200. See, 15.2 times 1,000 is equal to 15,200. So now let's go ahead and plug in our numbers here in our problem, okay? So our delta H is equal to negative 15,200 joules per mole plus the temperature, 325 Kelvin, times your delta S, 78.5 joules per mole dot Kelvin. All right, you should see what's going to cancel out, your kelvins. Now, bear with me because I already know what you're going to say. But wait, Professor T.K., the final answer is in kilojoules per mole, so why did we have to convert it? Well, in order to make this part of the problem work, because you can't add kilojoules with a joule. You cannot say kilojoules plus a joule. You have to say joules plus joules. So you convert it to a joule, get your final answer, then divide it by 1,000. Okay? So let's go ahead and do that now. We've got, well, but first we need to do this part right here first. Okay? 325 times 78.5 gives us 25,512. We're going to use that entire number because then at the very end is when we will use the correct sig figs, okay? So delta H is equal to negative 15,200 plus 25,512.5, okay? I'm not including the units because of space, okay? Just for the purpose of doing this. So let's plug this in. We've got 15,200, but that's negative, okay? Plus 25,512.50. And we get 10,312.5 joules per mole. But now remember, we don't want that as our final answer in terms of the units. The units have to be what? In kilojoules. So what you're going to do, you're going to divide this number right here by 1,000. Okay? Divide that by 1,000. And you end up with letter A. Okay. Number five.